Math is super fun. Slope is rise over run. I be chillin' in the sun, yeah. Singing math is super fun. Math is...
Hey guys, let's go over Stats Lesson 3.5, Sampling and Surveys. Learning target number 1, explain how under coverage, or another word for under is less coverage, lead to bias. Learning target number 2, explain how non-response or no responses can lead to bias. And then number 3, learning target number 3, explain how other aspects of a sample survey can lead to bias. Okay? All right. Learning target number 1. Even when samples are selected at random, there are potential sources of bias in a survey. Survey is where you get data. Bias is not an equal chance of picking, something. Number 2, under coverage occurs when some members of the population are less likely to be chosen or cannot be chosen for the sample. Under coverage, UC, leads to bias when the undercovered individuals differ from the population in ways that affect their responses. I think of 2 examples. Example number 1, the voting for the president recently. There's an undercoverage if somehow people like maybe who live far away from voting stations don't get to vote, right? And maybe there's so many people, for some reason, they've unfairly put the voting stations away from either people from faraway destinations that they don't get a chance to vote. My second example might be like seniors. And of course, as a senior, more pressure to kind of think about your future. So they ask only seniors, right? They go into a senior government class, who wants to go to college. And then, the proportion says, 95% of students want to go to a 4-year university. And then administration says, hey, look, at Savannah High School, 95% of our students want to go to college. Well, there's undercoverage because, we didn't really think about the freshmen, sophomores, and juniors. Okay, let's do example number 1. Example 1, ain't it a doggone shame? What proportion of dogs are malnourished or don't have enough food? A veterinarian examines the records of a random sample of 100 dogs. So I'm going to circle this, and I'm just going to write n equals 100. Enrolled in her practice and finds that 2% of these dogs, so there is a proportion there, a parameter. Sorry, these are just a sample, so that's a statistic, right? Because it's only a sample of 100 dogs, so 2% of the dogs are malnourished. Describe how undercoverage might lead to bias in the study and explain the likely direction of the bias. So, dogs enrolled in a veterinarian practice are likely to have owners remember the keyword likely, we're not saying for certain, but strongly, owners who take better care of their dogs, or of them, rather than, what's the opposite of being enrolled into a vet having a doctor rather than other owners on average. If I'm going to pay that hospital bill and I have a doctor, a animal doctor, a veterinarian, and he's right there, most likely those dogs are going to be taken care of. But if I'm like, I don't want to pay the extra money for my dog, you're probably like less caring about that dog, and most likely they'll probably be malnourished. So, do we think, what do we think about the direction of the bias? Because the sample includes only dogs enrolled in a veterinarian practice. The estimate, because we don't know everything about all the dogs, but we're kind of using statistics here. The estimate of the percentage of malnourished dogs is likely to be too low. Okay, so let's draw that graph to help us understand. We're saying that the 2% is here. But is that the true amount of dogs that are malnourished? No, we think the actual number is probably lower than that. I'm sorry, that 2% is too low. And we probably have dogs that are more malnourished. Maybe 5% of the dogs. Why am I saying that? Again, the 2% is those who have a veterinary doctor. You're paying money, hundreds and thousands of dollars to get your dog checked up. So the bias, the people who are actually not in, who don't have a veterinary doctor, most likely their dogs are going to be malnourished. So there's more dogs. So that number of 2% is too low. That's why I have it lower than the 5%. Okay. Learning target number 2. Explain how non-response can lead to bias. Even if every member of the population is equally likely to be selected for a sample, not all members of the population are equally likely to provide a response. Number 2, non-response. So this is the key vocab word there, or no response. Under coverage was the other one up here. Occurs when an individual chosen for the sample can't be contacted, can't find them, or refuses to participate. NR, non-response leads to a bias when individuals who can't, we already said that. I'll take that out. I'll delete it from yours. So for example, it's kind of like people who, they do a phone interview. Well, what happens if you don't have a phone? How can they contact you? Does that make sense? Or people might say on the radio like, text message in your response now to win this prize, or I don't know, drawing or something like that. Well, there's some people who don't have cell phones or don't have text message on their phone plans. So theirs would be a non-response. They can't respond or can't be contacted. Let's do example number 2. How much do you make? A recent alumni reunion alumni is just people who've already graduated. For a large university, a survey about the annual income was given to the 2,431 alums attending the reunion. Of the 42 alums who responded, the mean income was XBAR, an average of $132,473. Describe how non-response might lead to a bias in this study. Explain the likely direction of the bias. So let's think about this. If you were there and someone asked you, oh, how much do you make now after graduating from this large university? And you're like, I make $5,000. You'd probably be pretty ashamed and you probably wouldn't want to respond. That's why you would have no response. Does that make sense? So people who don't earn much money might be embarrassed and choose not to reply to the survey. On the other hand, if you make a lot of money, what would happen? People who have high incomes are probably very happy to share their financial success. So what's the direction of our bias? This means that the estimate from the sample is likely to be larger than the mean annual income for all 2,431 alums attending the reunion. All right, let's draw a visual, and this hopefully would make sense. Let's do it over here where I have some space. Here's my curve, and this is the true mean, the black line. Well, we're saying because of non-response, there is some biasm in there, right? Is everybody going to make 132,000? That's a lot of money. So let's just say this is 132K. I think the real mean is somewhere down here. I think maybe, I don't know, 80,000. Because the people who are responding in red are kind of bragging, oh yeah, I make a lot of money now. And the people who don't make a lot of money, towards the blue line, of course, they're not going to share anything because they feel kind of embarrassed. So the number that they're reporting is high. It's actually higher than what we think the green one will be, okay? All right, let's move on to learning target number 3. All right, learning target number 3, explain how other aspects of sampling survey can lead to bias. All right, so the first one here is called response bias. Occurs when there is a consistent pattern of inaccurate responses to a survey question. You're going to have to do this for a project. So pretend you ask students. This was a project of my students a couple years ago. Is you ask students whether they like Nike or Adidas. But the characteristics of the interview were they surveyed 20 people wearing Nike gear, and of course more people tend to say they like Nike. Or they did it another 20, but they dress up in all Adidas clothes. The characteristics of the interviewer can change how people respond. That's why it's called response bias. The second one is the wording of the question. So if I said something like a comment before I asked the question, I might say something like, "Oh, I hate those tree lovers, those tree huggers over there." And then I ask you the question, "Do you recycle?" Right? It kind of influences like, "Oh, I don't want to make me upset," right? Number 3, respondents being untruthful. Maybe it's a question that is controversial, like, say, to a teenager. If you ask them, "Hey, do you drink alcohol or do you cheat in school?" And the respondents may not want to be truthful because it kind of exposes them, so you might lie. So again, how people respond. And then number 4, the lack of being anonymous, or I don't know how to say anonymity. He's laughing at me. You can't be anonymous. You can't be truthful. Someone's going to know who you are, so sometimes people don't want to be honest. All right, let's try this next example here, and hopefully this will make sense. Example number 3, do the police speed? 2, what percent of police officers break the speed limit more than 3 times last week on their drive to work? A police officer surveys a random sample of 100 attendees. So again, I'm just practicing. I see SRS. This is a good thing. I see 100 attendees. So I'm going to write N equals 100. That is our sample size at a police officer's convention. And finds that 7%, this is my proportion there, of the response said yes. Describe how response bias might lead to bias in this survey. Explain the likely direction of the bias. So there's like a contradiction, right? Who usually writes the speeding, people who break the speed limit? Who usually, enforces the law? That's police officers. So it's kind of weird to find a police officer who contradicts themselves in this case because they don't want to expose themselves. So when asked in person, many officers might be embarrassed to admit they break the law. They were sworn to uphold. Right? You're basically like not doing your job. You're kind of being a hypocrite. The sample proportion, which is a 7%. Well, what do you think? Is it going to be smaller than or higher? It is likely less than the true proportion of all officers who break the speed limit. More than 3 times last week on their drive to work. All right, let's draw a picture. This might make more sense, okay? This normal distribution of officers that speed. And we said that the proportion in which they speed was 7%. So do you think the people that admit it, this is the true proportion, which we don't know, do you think it's going to be higher or lower? I think this number, 7%, like we just wrote, is going to be lower. Because I think more police officers would probably admit if the situation was, they can respond anonymously through a text, right? Maybe they do a survey as soon as they come in, or when they come in, maybe they go into a booth and no one knows and they can press yes or no. So I think this number is lower than what the true proportion or of actually police officers breaking the speed limit is. So this little visual, I don't know if it helps you. It helps me with the logic. You want to know, well, what's the truth? Do police officers speed? But again, the response bias is going to be based on, well, they don't really want to be truthful, because if they're writing a news article, and then they might write something bad about them. Okay, ways to help prevent bias. Well, selecting a SRS, simple random sample, is a good start. Taking steps to avoid undercoverage, we just learned about. That was in learning target number 1. Non-response, learning target number 2, and response bias, learning target number 3, can make surveys even better. Is there a solution? Yeah, write good statistical questions. Finally, it is a good idea to test out survey. That's how you give the questions out on a small group of people before administering it to the entire sample. This type of pilot study can help discover any problems with question wording or other unforeseen issues. So you start small and then keep getting it to the bigger. Okay? All right, let's go ahead and go on to page 3. You go ahead and try page 3 and then press play when you're ready. Example 4. Who did you say is calling? Literary Digest? One of the most famous flops in survey history occurred in 1936. To predict the outcome of the presidential election between Republican Alf Landon and Democrat Franklin D. Roosevelt, the magazine, Literary Digest, sent over 10 million ballots to its subscribers. They also sent ballots to registered owners of an automobile or telephone. About 2.4 million of the ballots were returned, with a large majority favoring Landon. The election turned out to be a landslide, but for Roosevelt instead of Landon. Explain how undercoverage might have led to the bias in the survey. Well, let's think about it. Who did they send the survey to? And then the question is, who did not send the survey to? So this survey displays undercoverage. Because people who did not have an automobile or telephone, your cell phone, car, were not sent a ballot. These people generally had less money than those who were sent a ballot. Less affluent or rich people at the time may have been more likely to support. So not rich, less affluent, poor people were more at that time may have been more likely to vote or support a Democrat. Okay, again, what's hard about statistics here is, yeah, you may not know the history, but there's some logical thinking about what's happening in here, and you have to kind of put it in context. So statistics here is kind of like, I need your reading skills, and I need the logical skills that come within mathematical thinking. Okay, explain how non-response may have led to bias in the survey. Well, did everybody return their ballots? How many were returned? 2.4 million ballots were returned. Which means, so 10 million, whoops, that's a million minus 2.4 million. It's going to give us 7.6 million ballots were not returned. So no response. Those people who did not return their ballots may have been too busy to respond because they were working too many hours. So if you don't have a lot of money, I don't know, I used to work at Jamba Juice, make a lot of money working at Jamba Juice, you're gonna have to work a lot of hours. Those people who are working many hours may have been less likely to support a Republican candidate. I forgot a little bit of my political history, but generally people who were the people kind of were Democrats. Okay, if the magazine followed up with people who didn't return their ballots and was able to attain responses, who would this eliminate the bias described in either A or Part B? Explain. So they went back to these people, following up with people who didn't return their ballots would not eliminate the bias due to undercoverage. Why? Because those people without an automobile or phone are still left out of the survey results. Following up will help to eliminate bias due to non-response. As a greater percentage will be contacted and surveyed. Because remember, the survey only went out to people who had an automobile or a phone. So if you didn't have a car, which probably cost a lot of money back then, and a phone, which means you're probably a poor person, then you were left out. So if you did the follow-up, like, hey, how come you didn't respond? Maybe they were just busy, didn't have time. That would just eliminate the non-response bias, because now the people have to kind of respond, right? You're at their door, they're not gonna, you can tell them, hey, I'm not going to leave until you take the survey. So let's just review quickly. We learned about, in 3.5, we learned about sampling and surveys. Learn target number 1, we talked about how undercoverage can lead to bias. Number 2, if you don't respond, it can also lead to bias, and there's other aspects of a sample survey that can also lead to a bias. So that's it. That is lesson 3.5.
Math
See you guys.
is
Bye.
super fun. Slope is rise over run. I be chillin' in the sun, yeah. Singing math is super fun. Math is super fun. Slope is rise over run. I be chillin' in the sun, yeah. Singing math is super fun.